In this lesson, which is the first lesson of Mod 9, we are going to be simplifying square roots. Now, let's take a minute to kind of look at the background of square roots. If you have a number and you raise it to the second power, that's of course also called squaring it, you get 5 squared is 25. 25 is considered a perfect square. If you have x and you square it, well, it is x squared. If you have x to the third and you square it, you get x to the sixth. So all of these in this right-hand column are perfect squares. Any variable raised to an even power is a perfect square, and then numbers that are the result of squaring other numbers are perfect squares. I have included here, and I will include in many of the lesson videos, you can check in your classroom and see if this power chart is available as a handout. If this first column is just a set of counting numbers, starting with 1, the second is x squared, so everything in this column is a perfect square. Everything in the third column is a perfect cube. It is, for instance, 8 is 2 to the third power. It's 2 times 2 times 2. The fourth column, these are all the numbers to the fourth power. These are numbers to the fifth power. You're probably not going to do much more than the first, dealing with squares. Once in a while, you'll look at cubes. It is very good to become familiar with the perfect squares. It'd be nice if you knew them up to at least 20. Perfect cubes, maybe to about 216. And you've met those before as you were dealing with factoring the sum or difference of cubes. All right, so now what are you going to be asked to do in this lesson? The inverse of squaring is square root. We're going to use a radical. That's what this symbol is. If you want to take the square root of 25, you're asked what number is squared to get it. So this is the inverse of squaring. If I want to take the cube root of the number, suppose I want to take the cube root of 8, then I include something called an index. If there is no index, it is implied to be a 2, but we don't write it. So when you don't see an index, it is still a 2. If I ask you what the cube root of 8 is, the answer is 2, because 2 to the third power is 8. Back up here with the variables, if we take the square root of x squared, I will say that x needs to be greater than or equal to 0 for this to be true. Don't worry about that too much. You'll see that concept revisited in college algebra maybe. It's equal to x. If I take the square root of x to the 10th, I'm saying what would you have to square to get x to the 10th? And the answer is x to the 5th. So some people get the idea right away that when you're taking the square root of a variable with an exponent, you're cutting the exponent in half. All right, let's look at some problems. I'm going to go ahead and enlarge this a little bit more. Well, I'm going to try to. There we go. Question number 1 says find the square root. What is the square root of 121? If you look at your chart or your calculator, 121 is a perfect square. Its square root is 11. If you need help with your individual calculator, talk to your teacher in your class. So here we would choose this one and put 11. When would you not have a square root? And we'll look at that in a few minutes. All right. What is negative of the square root of 100? This is just like there is a -1 times the square root of 100. The square root of 100 is 10. That negative on the outside says it is -10. This one says simplify by factoring. Well, we don't have to worry that much about factoring. We're saying what would be squared to get x to the 18th? Well, we talked about it a few minutes ago. It's x to the 9th. The reason, again, is because x to the 9th squared, you'd use the power rule, is x to the 18th. So that is just a little extra justification. What did you do? You cut the exponent in half only when you're doing square roots. All right, next one. Number 4 combines a numerical coefficient and a variable with an exponent. The square root of 16 is 4. The square root of x to the 6th is, and I hope you're thinking it, x to the 3rd. When you take the square root of a number, the radical sign is gone. It does not matter that this happens to be a perfect square still. You have taken the square root, the radical is gone. Next one. The square root of 9x to the 16th. The square root of 9 is 3. The square root of x to the 16th, you cut the exponent in half. It is 3x to the 8th. What is the opposite of the square root of 121? Well, we've visited 121 before. So the square root of 121 is 11. The negative on the outside stays with the answer. Number 7, what is the square root of x to the 6th? We take half of the exponent. It is x to the 3rd. Number 8 really sees if you've got the whole picture. The square root of 36, a to the 6th, b to the 22nd. Well, the square root of 36 is 6. The square root of a to the 6th is a to the 3rd. The square root of b to the 22nd is b to the 11th. You could check it. If you square this, you will get back to the inside of a radical is called the radicand. The inside of the radical is called the radicand. All right, number 9. The square root of a fraction, and at first people think that might be especially hard, but it's not. You take the square root of the numerator over the square root of the denominator. The square root of 4 is 2 over the square root of 49 is 7. If you know your perfect squares, at least up to about 25, that's great. Learn to use your calculator, be able to use the chart. You notice that each one of these has the option, the square root is not a real number. So let's talk about that for just a minute. If you were to take the square root of 25, it's equal to 5 because 5 squared is 25. If I ask you to take the square root of negative 25, well, if you guess 5, well, is 5 squared negative 25? The answer is no, so it can't be that. If you think the answer is negative 5, is negative 5, and it has to be in parentheses, squared, equal to negative 25? No, because any real number squared is going to equal a positive, with the exception of 0, because 0 squared is 0. Is there any way that I can find a number that if I square it, it is negative 25? The answer is no, not in the real numbers. We will, at the end of this unit, look at numbers that are not real. So, when you have, if you have, a radicand of a square root that is negative, the answer will not be real. So there is no real answer. This is not necessarily true about cube roots, but it is true about square roots. There aren't any of those in the homework, I don't think, but you will see them before this unit ends. Okay? It's time for you to do your homework.